The problem of making a machine to replicate human capabilities, such as intelligence, has fascinated many scientists for many centuries. The major efforts were directed to the computing capabilities. The first three examples that are worth being mentioned are related to the 17th century. In 1623, Wilhelm Sieghart, ancestor of the calculator, was able to carry out mathematical calculations with numbers up to 6 digits with machines, even if not autonomously. In 1642, Blaise Pascal invented a mechanical calculator capable of adding and subtracting two numbers directly and of performing multiplication and division through repeated addition and subtraction. In 1674, Gottfried Wilhelm von Leibniz invented a mechanical machine capable of performing the addition, subtraction, and multiplication by exploiting recursion. When moving to the 19th century, we can mention Charles Babbage. He proposed the model of differential engine, a machine capable of solving polynomials by using the finite differences method. This model was implemented by Georg and Edward Schultz in a working machine. Some years later, Charles Babbage proposed a model of a general-purpose computing machine capable of performing every kind of calculus, beyond those performed by the differential engine. This new model was called analytical engine. The development of electronic calculators in the middle of the 20th century paved the way to new ideas. In particular, Alan Turing proposed a theory of computation, according to which a machine, by shuffling symbols as simple as 0 and 1, could simulate any conceivable act of mathematical deduction. This model, known as the Turing machine, is the main computation model among those adopted today. In particular, Alonzo Charge and Alan Turing showed that digital computers can simulate any process and formal reasoning, and this was done by showing that the Turing machine is the most general computing machine one can design. Such a result, together with the last discoveries in neurobiology, information theory, and cybernetics, led researchers to consider the possibility of building an electronic brain. The first AI result is the artificial neuron called linear threshold unit, proposed by Warren McCulloch and Walter Pitts in 1943. The model was specifically targeted as a computational model of the nerve net in the brain. It was noticed that any Boolean function could be implemented by neural networks. What is easily seen from the fact that one can implement the AND and the OR functions and use them in the disjunctive or the conjunctive normal form. Researchers also soon realized that cyclic networks with feedback through neurons could define dynamical systems with memory. These results raised a lot of questions in the scientific community on what intelligence is and when an entity can be considered intelligent. These questions will be central in the works of Alan Turing.